Hello friends, welcome to the session on data structure. So let us start the session and let us discuss what we mean by searching in the linear arrays. As far as the searching in the linear arrays is concerned, we know that searching is just nothing but finding an element. Suppose you have been given an array. We know that array is a sequential collection of elements where the elements are stored in memory sequentially one after the other. The array can be either one-dimensional or the array can be two-dimensional. And whenever we have been provided with the array, then you will find that every element of the array will have a number, and that number we call as an index number. So through index number, we can make an access to the elements of the array. Friends, the concept of array is very important and it is frequently used by the programmer, because whenever we want to define any value in a program, then we need to make the use of a variable. But if you have been provided with a large set of values, then writing variable for each value separately is very difficult, and therefore array will provide you the solution. Array name will be only one and array index will be different, and with the help of the array we can store large amount of data in memory. So this is the advantage of array. So whenever you have been provided with the array, then every element can be accessed through its index number. If the array is one-dimensional, then the index is in the form of single integer. But if array is two-dimensional, then the index is in the form of a pair of numbers. Say for example, if I have a table of 3 rows and 3 columns, then my first element can be having the index 0, 0. The second element from the first row will have the index 0, 1. The third element from the first row will have the index 0, 2. And in this way, we can make an access to each and every element in the array. Now, whenever we have been provided with the array, and now we want to find out a certain element from the array. Now, whenever you want to find out whether the element is present in the array or not, you need to do the search operation. Now, searching can be of two types. Say for example, we have the search called as the linear search, and the another search is being called as a binary search. So linear search is the most simplest type of the search, and you will find that the writing algorithm for the linear search is very easy. Binary search is very popular because the number of comparisons that we need to make in the binary search much less, and therefore binary search is popular, but writing algorithm for binary search is bit difficult. As far as this session is concerned, we will discuss the linear search operation for the linear array, and for the binary search we will go for the next session. So let us start the discussion what we mean by searching in the array. As we know that whenever we write any algorithm for performing any operation on the array, then every algorithm is being associated with a concept called as the complexity. So complexity of the algorithm is measured in terms of the comparisons. As far as the search operation is concerned, how many comparisons you are going to make in order to find the element, that is very important. And the more number of comparisons that you need to perform, it means that the complexity will be more. If the comparisons are less, then the complexity will be less as far as the searching operation is concerned. And therefore, you should always choose only that algorithm where the number of comparisons are much less. But as far as linear search operation is concerned, as I said, it is the simplest type of the searching operation, but it requires more number of comparisons, and therefore the complexity of the linear search is higher than that of the binary search. So let us understand what we mean by the linear search and how we can perform the linear search. Linear search is a very simple method. In this method, what is done is that you have been provided with some array and you have been provided with some search element. Now what you need to do is that you have to compare the search element with the first element first, and then go on to the second element, and then go on to the third element, and this process will go on until you find the element or you reach to the end of the array. Say for example, we have been provided with an array as shown in this diagram. Suppose the first element is A, the second element is B, the third element is C, and in this way my last element is M. So all of these elements are having the indices starting from 0 to 12. Now suppose I want to find out the element J in the array. Now what I will do, is that I will compare this j with the first element. My first element is a and my search element is j. Therefore, they do not match with each other. Therefore, I will go for the next element. The second element is b. My search element is j. They do not match with each other, and therefore I will go for the third element. So this process goes on until I reach to the element having index 9. You will find that at index 9, my search element j matches with the array element j, and therefore now my searching will be stopped because I have already found the element in the array. My searching will be stopped, and I will say that the element is present in the array at the position of index 9. So this will be the output of my algorithm. Sometimes what happens that the element is not present in the entire array. In such a case, what we will do is that we will go to the end of the array, and if the element doesn't match with any element of the array, in that case we will give the output that the match element or the search element do not match with any one of the element of the array, and therefore the element is not found. So this is, as I said, this is the simplest type of the search algorithm, and the complexity of the algorithm is of the order of n, because if you have been provided an array with n elements, then the number of comparisons that you need to perform is n, and therefore the complexity of the algorithm is of the order of n. So this notation, that notation which is being used to describe the complexity, is being called as a big O notation. So big O notation will give us the worst case. So the worst possible case of searching the element is n, means you need to make n number of comparisons whenever you write the linear search. Now let us understand the algorithm, how to write the algorithm for the linear search. In this window you will find that the algorithm is being given. Suppose we have been provided with an array A, and suppose my search element is x. Now initially what I will do, I will set the initial counter I is equal to 1. So you can set it I is equal to 1, or sometimes you can set it I is equal to 0. If your index starts from 0, you can set it to 0 also. And I will go on checking whether I is greater than or equal to n. And if I is greater than or equal to n, then I will go to the step number 7, where we will display the message that the element is not found. It means that what we are doing is that we have been setting up a counter, and every time we will be incrementing the counter by 1, and every time we will be comparing the search element with the element of the array, and this process will go on until we reach to the end of the array. So whether we have reached to the end of the array is being indicated by this step 2. If I becomes greater than 1, when I becomes greater than 1, it means we have already surpassed all the elements of the array, and therefore we will stop and we will declare that the element is not found. Otherwise, what we will do is that we will compare the value of the element of the array with the search element x, and this comparison can be done by using this step number 3, if ai is equal to x. So this is a way we can write the element of the array. A is the name of the array, and in the bracket we write I. So value of I is initially 1. Therefore A1 will be the first element of the array, and we will check whether A1 matches with the given x value. And if it matches, then we will go to the step number 6. And in the step number 6, you will find that we will simply print the message that we have found x at the position of I, and then we will go to the step 8, where step 8 will be the exit step. So once the match is found, then further searching is not required. Therefore, if the match is found in the first element itself, we will exit the algorithm. If the match is not found, then in that case we will go to the step number 4, where we will increment the value of I by 1, and then again we will go back to the step number 2. And in the step number 2, again we will check whether the value of I has become greater than 1. If it is less than n, then we will go on repeating the steps. So this is the algorithm that is being used for the linear search. And as I said, as far as searching is concerned, this is the simplest type of the searching we can have. Now let us understand one simple example so that you can understand how exactly this searching operation is being performed. Suppose we have been given one array, and in this array, suppose there are these elements. The first element is 5, the second element is 15, the third element is 3, fourth element is 25, and the fifth element is 75. So what I am doing is that I am considering an array where there are 5 elements. And now suppose my search element x is 3. So what I will do according to this algorithm, linear search, I will first of all compare this x with the 5. If the match is found, then I will stop. But I know that the value 5 do not match with 3, and therefore what I will do is that I will increment the counter and then I will go to the next element. And I will compare the value of 15 with 3. Again I will find that 15 do not match with 3. So I will go to the next element. So you will find that now next element having the value 3, my search element is also having the value 3. So the match is found. Once the match is found, then I will stop searching, and what I will do is that I will display the result that the index at index 3 the match is being found. So I will display the index value, the position of the array element where the match is being found. So this is the way the algorithm works. If I have been given the search element, say 95, suppose my search element is 95, and now what I will do, I will compare it with 5 first, then I will compare it with 15, then I will compare it with 3, then I will compare it 25, then I will compare it with 75, and I have already reached to the end of the array, and now the match is not found. So what I will do, in such a case the algorithm will display the result that the match is not found in the array. So this is the way the algorithm of linear search works. So thank you friends for viewing the session. Hopefully you have understood what we mean by the linear search and how exactly this linear search algorithm works. Thank you all for viewing the session.